All right, let's take a look at some more examples from probability. So just take a moment to familiarize yourself with this pie chart here and take a read of the question that you see on the screen. All right, so we're going to use this information to answer some questions. So the first question says to estimate the number of people 25 or older who have high school diplomas. So looking at the pie chart that we see here, we can look at who has a high school diploma. So high school graduate has a high school diploma. But there are more than just that category that have a high school diploma, because in order to go to college, you have to have a high school diploma. In order to get an associate's degree, you had to have graduated from high school, as well as a bachelor's degree and an advanced degree. So here we have one of two options. We can add up each of those percentages. So 32 plus 17 plus 8.4 plus 18.1 plus 9.7. Or we can also just take this one category that's not a high school diploma, which would be 14.8%, and subtract that from 100. And so that's the way that I'm going to do this problem. And so since 14.8% are not high school graduates, that would mean that 85.2% have high school diplomas. Converting that to a decimal, we have 0.852, and then we multiply that by the population, which is 186.88 million. And then simplifying that, we can see that 159.222 million people, 25 or older, have a high school diploma. All right, let's go on to part B. Part B asks us to find the probability that a person 25 or older selected at random has earned an associate's degree or a bachelor's degree. All right, so we can look for those two categories. So looking for associate's degree first, I can see associate's degree right here, 8.4%, or a bachelor's degree. So let's see, bachelor's degree right here, 18.1%. So since this says the word or in there, then I know that this means I'm going to add those values together. And so going ahead and doing that, I have my 8.4 for an associate's degree, 18.1 for a bachelor's degree. Adding those two together as decimals for probability, I have 0.084 plus 0.181, and that tells me that 0.265 is the probability of a person 25 or older having either an associate's degree or a bachelor's degree. All right, very good. So there's some examples of how you can use a pie chart to calculate different probabilities and find information. Let's go ahead and take a look at example 7. So example 7 says in a high school graduating class of 128 students, 52 are on the honor roll. Of these, 48 are going on to college. Of the other 76 students, 56 are going on to college. A student who is selected at random from the class. What is the probability that that person chosen is either of these three different options? Oh my goodness, so this is a lot of information here. So let's first kind of pull out some information. So we have a total of 128 students, and that's broken down essentially into two categories of those that made the honor roll and those that did not make the honor roll. So 52 made the honor roll, and then 76 means that this is not on the honor roll. And then we talk about whether or not these students are going to college. And so the college is broken down into two groups as well. So 48 are going to college that were also on the honor roll, and then 56 are going to college that were not on the honor roll. Okay? All right. So to answer these questions, you can just try and figure it out and do some calculations, but I like to organize the information into a chart so I don't make any mistakes. It's really easy to make a mistake. So I like to organize it with a chart like this. And so this chart has the different categories. It has going to college, not going to college, on the honor roll, not on the honor roll. Okay? So take a moment and see if you can figure out the numbers that go into each of these charts or each of these boxes. So like this box right here would be students that are going to college and are on the honor roll. So thinking about that, how many students are going to college and on the honor roll? And if we look back, we saw that there was 52 on the honor roll, and of those, 48 are going to college. So that looks like this number would be 48. So go ahead and see if you can fill in the other three spots. And then also, in the end, do the total. So this would be the total going across. That's the total going across. And then on the bottom, also do the total going vertical. Okay. And then to check your answer, what you can see is you can see that you need to have in the bottom right-hand corner, this number here should total both vertically and horizontally. And if it does, then you have your correct, or hopefully you have the correct answer. So go ahead and see if you can complete this chart. All right, let's see how you did on the chart. Okay, so here we can see that 104 plus 24 is equal to 128, as well as 52 plus 76 is equal to 128. If you go across here, 48 plus 4 is 52, and 56 plus 20 is 76. And then also vertically, this gives us 104, this gives us 24. Okay, all right, so now we can use this information to answer the questions. So going to college. So we're looking for what is the probability of a student going to college. So probability of college. Well, let's see, how many are total are going to college? The total going to college is right down here. It's 104. So 104 out of how many total students? That's 128. And then we just reduce that number. I ran out of space there, so something like this equals, and that would be 13 out of 16. Okay. So then that's the probability that are going to college. Second question is probability of not going to college. So probability of not college would equal the complement of going to college. So it would be 1 minus the probability of college. And so that's 1 minus 13/16. So I can just look at that for not college. And then I have 3 out of 16. I could have also done that by saying, okay, well, there's 24 out of 128, and 24 out of 128 also reduces to 3/16. So just different ways to think about the problem. All right, and then the last one that we have here is the probability of not going to college and, so multiply on the honor roll. Okay, so probability of no college and honor roll. So I'm gonna put HR for honor roll. So we know we're gonna have a multiplication there. But actually we have this in our chart, so we don't actually need to multiply. So going to college, if I look at that column to figure out where is my going to college column. So going to college is this column. And then on the honor roll is this row. So that where's the overlap right there? That's 48. And so that's going to be, sorry, that's not going to college. So not this one, scratch that. Not going to college is this one. So that's 4 out of the total of 128. Okay, so here we have then just 4 out of 128. And if I reduce that, I get 1 out of 32. Okay, so this is just an example of how you can organize some of your information so that you can more easily answer the questions when you have some complex situations where things overlap. All right. The next example we're going to continue with, I'm going to have you go ahead and start this problem. And I want you to start it by, let's see, I'm just going to pick one of them. Let's have you do the probability. Let's have you start with C. So I want you to do part C. Actually, we're going to do part C together, sorry. And then I'm going to have you guys do part A, part B, and part D on your own, and we're going to look for some patterns. Okay, so 3 dice are rolled, and I want to find the probability of rolling 1 6. So if I'm rolling 3 dice, so 3 dice, and I want to roll 1 6. So it's either a 6, so the options are a 6, okay, or not a 6. All right, we don't care if it's a 1, if it's a 2, if it's a 3, if it's a 4, if it's a 5. All we care about, it's either a 6 or it's not a 6. Okay, so another way that I can write this not a 6 is I'm going to write it as 6 with a C on top, kind of like in the exponent position. So that means the complement of rolling a 6, which would be everything that's not a 6. Okay, so 3 dice are rolled, and I'm finding the probability of a 6 or not a 6. So I only have 2 options. So I'm going to start by building a tree diagram. Okay, so my first dice could either be a 6 or it could be not a 6. So I'm going to start with, okay, well, my first one is either a 6 or it's not a 6. My second one then also is a 6 or it's not a 6. And I do this for 3 times, right? 6 or not a 6. So go ahead and continue building your tree diagram. And then we're going to answer question C. All right, let me get rid of this just to make this tree diagram look pretty. So here's my tree diagram. So you can see my 6s are all in purple. My complements, so not a 6, is in yellow. All right, and I want the probability of just 1 6. So the top one has 3 6s. So essentially I'm going to need 1 6 and 2 complements. So this one right here would be 1 6 and 2 complements. And right here would be 1 6 and then 1 and then 2 not 6. And let's see. 1 6, 2 complements. 1 6. Right here would also be 1 6 and 2 complements. Okay, so I have 3 different options there for my probability of 1 6. So I'm going to go ahead and just trace those out, and I'm going to write the probabilities. So here, this first path is a 6, and then it's not a 6, and then it's also not a 6. So 1 6, 2 complements. My second path would be not a 6, then a 6, then not a 6, or not a 6, not a 6, and then the third one would be a 6. Okay, so if I write each of those probabilities on those branches, remembering what we did in the first set of examples. My pen's not changing colors here. Okay. All right, so this first one, so if my first one is not a 6, so let's see, I have 1 6 here. Sorry, not a 6. I would have 5 options out of 6, right? This is my start right here. Start. So my first one is not a 6. So it's 5 out of 6 options for not a 6, right? Because it could be 1, 2, 3, 4, or 5. Then my next branch would be, okay, 1 out of 6. So it has to be a 6, so it's 1 out of 6. Then this is not a 6, so then it's 5 out of 6. Okay? And then I'm going to do that for each of the 3 different paths. I don't know why I did the middle one first, but I'll do the one at the bottom now. So then complement of 6 would be 5 6, and then a 6 would be 1 6. Then up at the top, the one that I have there at the top, is going to be 1 6, and then it's going to be 5 6, and then it's going to be 5 6. So you can see that each of the probabilities that I have, should highlight that first little piece. Each of the probabilities that I have is either 1 6 or 5 6 from dice or from roll to roll. Okay. All right. So summarizing that and writing that out, then what I have here, let's go here. So probability of 1 6 is going to be, let's see, the path on the top. Okay. The first path is 1 6 times 5 6 times 5 6. All right. The middle path starts with 5 6, then 1 6, then 5 6, and then the last path is 5 6, 5 6, and 1 6. All right. Now, if I look at these, each of these has 2 5 6. Each term has 2 5 6 and 1 1 6. So I can rewrite that as I have 3 terms that are 1 6 times, and then I have 2 5 6, 5 over 6, and that's going to be squared. Okay, cool. And then I would go ahead and I would calculate that out, but you're just going to leave it at that point. So just leave your answer like this in simplified form, but you don't need to multiply it all out. So go ahead, pause the video, and I want you to complete A, B, and D. And you can work by yourself or you can work with a partner, but check with people around you when you finish. Okay, pause the video now. All right, let's take a look and see where we're at with this. So check your answers. Part A is 1 6 cubed. Part B is 3 times 1 6 squared times 5 6. And part D is 5 6 cubed. Now, what I want you guys to notice, that each of these has a 1 6 and a 5 6 in it. with the exception of A and D, but I could write a 1/6 and a 5/6 in both A and D. So I can say that 1/6 cubed, okay, so I have that part, 1/6 quantity cubed. And then I could say it's really 5/6 to the 0 power, okay? In the bottom part D, I could say that this is 1/6 to the 0 and then 5/6 cubed. So now they each have a 1/6 and a 5/6, right? So looking at that, I'm just going to highlight some common things here. So we each have a 1/6 and then a 5/6. Sorry about that. Highlighter. Okay, so we have a 1/6. Didn't want to do that one. So sorry, 1/6 right here, 1/6. Then we have 1/6. Then we have 1/6, and then we have 1/6. And then they each have a 5/6. So I'll go green. So we have 5/6, 5/6, 5/6, and 5/6. And each of those has an exponent on it. Okay. And then they each also have a coefficient. So the coefficient here, we don't have anything, but that coefficient would be a 1. Coefficient's a 3. Coefficient's a 3. Coefficient here would also be a 1. So I'm going to go ahead and fill those coefficients in. So this would be a 1 there and a 1 there. Okay. Now, if I look at the coefficients on these, this is really interesting. Take a look and see if you can see any patterns with the coefficients, and stop the video and chat with somebody around you, or just think through it. All right, so some things you may have noticed. You may have noticed that the coefficients here follow the same as the binomial theorem or Pascal's triangle, right? The coefficients are 1, then 3, then 3, then 1. And notice that part A is 3 sixes, then we're reducing the number of sixes by 1. So then part B is 2 sixes, then 1/6, and then 0/6. And then with the exponents, the exponent that's on the 1/6, if we're looking for 3 sixes, the exponent is 1/6, or sorry, the exponent is 3 on the 1/6. If we're looking for 2 sixes, the exponent is 2 on the 1/6. If we're looking at if we're looking just for 1/6, we can see that the exponent on the 1/6 is just 1, and we have 0 sixes, the exponent on the 1/6 is 1. And so those numbers match. Maybe I'm going to write that, just show that in purple. So 3 sixes, the probability of a 6. Oh, sorry, let me get rid of that real quick. Go to my pen, not my highlighter. So if we want 3 sixes, the probability of a 6 is 1/6, and the exponent is 3. 2, exponent is 2, 1, the exponent is 1, and 0, exponent is 0. And then we're thinking about the complement. What's the probability of the complement? The complement is 5/6. Oh, then look at these exponents. You have a 3 and a 0, that adds up to 3. A 2 plus a 1 adds up to 3. A 1 plus a 2 adds up to 3. And a 0 plus a 3 adds up to 3. So hopefully what you can start to see here is you can start to see the terms of the binomial theorem. And so this binomial theorem is represented in this type of probability, which is called binomial probability. Okay, so we have those coefficients, and then we have the probability and the probability of the complement with the appropriate exponents to match. So I know there's a lot going on there. You can pause the video if you'd like and just kind of think through all the things I just said and try and process it all, and then continue on. All right, continuing on, as I said, this was called binomial probability. And binomial probability has some conditions to it. So it exists if and only if the following conditions occur. There are exactly 2 possible outcomes. So in the last example, we either had a 6 or not a 6. Okay. We also could do like flipping a coin. It's either a head or it's a tail. Or answering a question yes or no. It's either yes or it's no. Or getting a question right or wrong on a test. It's either correct, it's right, or it's wrong. All right, the other thing, there's a fixed number of trials. So you're not doing this infinitely. but there's a fixed number of trials. So on the previous example, we had 3 trials because we had 3 dice. Okay, so a fixed number of trials. Number of questions on a test, if you had like a 25 question test, it's either correct or it's incorrect, and you have 25 total questions, so fixed number of trials. These trials are independent. So for rolling the dice, rolling 1 dice is not going to affect, or the outcome of 1 dice does not affect the outcome of a 2nd dice or the 3rd dice. Okay. And then the probability of each trial is the same. So what that means is that the probability of a 6 on the 1st dice is the same as the probability of a 6 on the 2nd dice. And then this is the same as the probability of a 6 on the 3rd dice. Okay, so those are the 4 criteria that need to be met in order to be considered a binomial probability question. So once you identify that we have a binomial probability question, then you can use the binomial theorem to answer the question. So I know the last example had a lot going on, so I just wanted you guys to see the binomial that was in there. And so let's look at it with one specific question where you're just asked to find one term. Okay, so this question here says, to practice for a jigsaw puzzle competition, Chad and Rashad put together 7 jigsaw puzzles. The probability that Chad puts in the last piece of the puzzle is 1/5. The probability that Rashad puts in the last piece of the puzzle is 4/5. What is the probability that Chad will put in the last piece of the puzzle? The last piece of 3 puzzles. Okay, so let's run through the criteria for binomial probability. This one is binomial probability, but we need to identify that. You can't just expect me to tell you because I won't always tell you. And you'll need to figure that out for yourself on the test. Okay, so some pieces of information. First, there are exactly 2 possible outcomes. Okay, yes, there are exactly 2 possible outcomes. So the 2 possible outcomes are either Chad puts in the puzzle piece or Rashad puts in the last puzzle piece. So it's either Chad puts it in or Rashad puts it in. So there's 2 possible outcomes. Second criteria, there's a fixed number of trials. Well, it says that we're working with 3 puzzles, right? So there's a fixed number of trials because there are, not 3 puzzles. That's how many you want there. They're putting together 7 total puzzles. So we have a total of 7 puzzles. Okay, so there's a fixed number of trials, which are puzzles. Then the trials are independent. The trials are independent, okay, because we can see that either Chad puts in a puzzle piece or Rashad puts in the last puzzle piece. So if Chad puts in the last puzzle piece, that's 1/5 for Chad. And if Rashad puts in the last puzzle piece, Rashad's probability is 4/5. Okay. And then the last thing, the probability of each trial is the same. The trials are independent is what I figured out, or I forgot, I think. So yeah, they're independent because whoever puts in the last puzzle piece on puzzle number 1, it doesn't affect who's going to put the last puzzle piece in on puzzle number 2. Okay, so what we are looking for then here in this problem is we're looking for the probability that Chad will put in the last piece of 3 puzzles. All right, so we're looking for Chad putting the last piece on 3 puzzles. So what I want is I want to figure out what is the probability, get with my pen here, okay, the probability that Chad is, I'm going to put equals 3 for 3 puzzles. So Chad is 3 puzzles, which means then this implies that Rashad put in the last puzzle piece on the other 4 puzzles. Okay, so this probability is going to be this. You have a total number of 7 puzzles, and you're going to choose 3 of them that you want Chad to put in the last puzzle piece on. Okay, the probability that Chad will put in a puzzle piece is 1/5, and he's going to do that 3 times. And the probability that Rashad puts in a puzzle piece, the last puzzle piece, is 4/5, and he's going to do that 4 times. Okay, and then we just calculate this. So you can use your calculator to calculate this and plug it in. You could do, 7 factorial over 4 factorial, 3 factorial times 1/5 cubed. If you want, I don't recommend it. Use your calculator to plug this in, and we get the probability that Chad puts in a puzzle piece, the last puzzle piece on 3 puzzles, is 0.1146. 7. All right, very good. Okay, we're almost done. Got 2 more here. So same information from the last example. So using the information from number 9, what is the probability that Chad will put in the last puzzle piece of at least 2 puzzles? So at least means that Chad would put in more than or equal to 2 puzzles. Okay, so let's see what that would look like. I can write this like this. The probability that Chad is greater than or equal to 2, so this is at least 2, would mean that he puts in 2 and then Rashad puts in 5, or Chad could put in 3 and Rashad would put in 4, or Chad would put in for 4 and Rashad would put in 3, or Chad would put in 5, Rashad 2, or Chad 6, Rashad 1, or Chad all 7 and Rashad 0. Okay. Oh my gosh, this is a lot of terms. So the first term, let's see here. I'm just going to write out the first term and then I'll show you the whole solution. So this first term right here, probability that Chad is 2 and Rashad is 5. Okay, so I would do, let's see here. I would do, so equals this first one right here. This is just the first term. So I would have 7 choose 2, and then I would have Chad's probability, which was 1/5 squared, Rashad's probability, which is 4/5 to the 5th. Then I would have plus, and I would go again. This next term, 7 choose 3, 1/5 cubed times 4/5 to the 4th plus, and so on. So go ahead and continue writing this out. Oh my gosh, that's taking a long time. Okay, let me just get rid of that so I can make it nice and pretty on the screen for you. So let me just show you this answer. So if you write them all out, you're going to get this. Now notice I wrote this, C 7,2. That's the same as 7 choose 2. Okay, just an easier way to type it for me. And that's a lot of terms that I have to add together. Of course I would use my calculator. When I use my calculator and I plug this in, I end up with this answer. All right, I don't expect you to go as fast as I did there, but that's what I would get. Now, that's a lot of terms. I don't necessarily want to have to do all of those terms. So let me think about another way that I could do this problem. So same question. Chad is going to put the last puzzle piece in of at least 2 puzzles. Well, if he does at least 2 puzzles, that means not 0 puzzles, not 1 puzzle. Right? So it's not, this here is not less than 2. We want everything that's not less than 2. So I can do this with a complement. So complement's going to be a little bit easier in this problem. And again, this is just another strategy for you to think about and consider. So the probability that Chad would put in at least 2 is the complement, so 1 minus the probability that Chad would put in less than 2. Right? Less than 2 is much quicker to calculate because there's only 2 terms. So the 2 terms that we have for less than 2 would be Chad puts in 0, Rashad puts in 7, Chad puts in 1, Rashad puts in 6. And then I only have those 2 terms to calculate. So I have this, much less to put into my calculator. And when I calculate that, I get the same answer, that probability of Chad greater than or equal to 2 is 0.4232. All right, so that's binomial probability. Now, just remember that you can only use binomial probability when you have a binomial situation, and that binomial situation are these 4 criteria that we had on this previous screen. Oh, we can't get back to it. Right here, right? We have to have those 4 criteria. If not, it's not binomial and don't use this method. All right, that's enough for probability examples.